Hi, my name is Sriraj and this is the presentation of my 3D printed project, which is a three-dimensional layout of a residential building floor plan, or 3D building. Since the course required my project to be related to my major, which is construction management, the purpose of my project was to print a 3D building layout of a residential floor plan. My design goal was to design a house plan which is realistic, something which resembles a real house, and also something which is within the printing scope of a LustBot task. The objective of my project was to turn this design to reality. Let's take a look at the process which I followed to achieve this objective. Step 1 of the process was to design the floor plan in Autodesk AutoCAD. A 2D layout of the house with walls and stairs was designed as shown in the image. The walls and stairs were then extruded and openings were created in the walls. The furniture element of table and chairs was then added to the layout. The final model can be seen in the image. Step 2 of the process was to generate the G-code. The model shown in the previous slide was saved as a .stl file. That file was imported in Cura. The scale of the model was then reduced by half to fit the dimensions within the printing scope of a LustBot task. The parameters which were set in Cura can be seen in the image. 2.85 mm ABS filament was used to print this model. The print and bed temperatures were set accordingly. Fill density was set to 20%. Since the model contained openings, support was provided everywhere. The G-code was finally generated and then copied to an SD card. The third and final step was to print the model. The printer in the Idea to Product lab, which is named Sputnik, was used to print this model. I would like to thank the lab staff who guided me to set up the filament and printer base. Printing took the 23 hours to complete. Let's have a look at the finished products. This is the final printed model. This image is taken before removing the support material. As you can see, the walls and stairs printed really good, but the print of table and chairs was flimsy and didn't last long. After the support material was removed, it can be seen in the image that the openings turned out quite good. The second image shows a close-up of stairs. As it can be seen, the stairs also turned out quite sharp. Let's take a look at some of the things which I learned in the process. The model was designed at a higher scale, which was then reduced to fit within the printer. If the design is made keeping the printer limits in mind, printing of more complex designs can be attempted. The flimsiness of furniture elements can be because of low fill density. Higher fill density may result in sturdy product. The chairs and tables in the design had very high requirement of support material. The support material was higher than the product material itself, which resulted in a bad output. Also, there were minor errors in design. The stair landing was designed in the middle of a window opening. Such errors should have been eliminated at the design stage. I would do the following things differently when I print again. I would attempt a more complex design. If I get access to a compatible printer, I may print with a different filament. I would like to print some furniture elements at higher fill density requiring less support materials to see how the output is. I would also attempt to print parts of a larger model like a multi-storied building. To summarize, this class was a great learning experience and it increased my curiosity about the applications of 3D printing in construction. Thank you for watching my presentation.